Hey guys, we'll get started in a minute or two. Just give a few more opportunities for latecomers to turn up. Today's lesson, we're going to be looking at linear equations, just a very quick summary or revision of the Year 8 and Year 9 content, and then just looking at interpreting linear equations, looking at the key features of them and how they correspond to key features of graphs of linear equations. And then we'll also look at the properties of parallel and perpendicular lines, how to prove that they're perpendicular, and a few other questions to do with that. If there's anything in particular in those topics you really want me to go over, please let me know. There's not many of us here today, so I'm more than happy to tailor this lesson to whatever it is that you guys are currently learning or want to learn about. So if there's something else that's not covered, I'm more than happy to go off on a tangent and cover that instead. So you can just leave a comment in the chat if that's something you'd be interested in doing. Vectors and scalars. Ooh, I did look actually at a few challenge questions involving vectors and scalars, but they're not really covered in Year 10 at all. If there's time at the end, we can go back and look at them. That's a good idea. It's one of those topics that you learn a lot more about in uni and then wonder why you didn't actually learn them in high school. It'll make things a lot easier. Okay, it's 3 past, so we'll get going. I'll try and keep the chat open and keep an eye on it. If I'm going too fast or too slow, please let me know and we'll adjust accordingly. Okay, so this week, as I said, we'll be looking at interpreting linear relationships and parallel and perpendicular lines. Okay, let's have a, as usual, housekeeping stuff. You know all this. I think everyone here has been on one of these before. You've got your links to the YouTube topic videos on all the corresponding topics. Okay, let's just start up with a warm-up table of values. So this is probably hard Year 8, easier Year 9 level. What is the gradient of the line? Write the equation of the line in y equals mx plus c form, and then just state what the y-intercept is. Shouldn't take too long. We'll give a couple of minutes to quickly solve this one, and then we'll look at a few more features. So important things to note. The x values aren't increasing by 1, they're going up by 6. So you'll need to factor that in when you're finding the gradient. And then we'll need to do a bit of manipulation to find the y-intercept. Well, once you've got your equation, it should be obvious what the y-intercept is. Some of you might want to find the y-intercept first, and that'll help you write the equation. Oh, yes, the code. Of course, the important things. Yeah, how do I get that? So, how do I get the code? Start lesson. That's what I did, didn't I? Ah, start lesson, not present. Sorry, guys, you couldn't see what I was talking about. I thought someone wanted to be taught about codes. I think in Victoria, I believe you do a bit of coding in Year 7 mathematics these days. There we go. Broke bandanas form troubling elephants. Can you see it on the screen, guys? Or did it? I put the code in the chat just in case you couldn't. I'm a bit lost as to which thing I'm presenting. got 5 connected. I'll just start. All right. Knew I'd forgotten something. Why are you not full screen? Okay, here we are. As we are going, I'll just show you the method I would probably use. So you can see here, let's increase by 12, and from here, we've increased by 6. If we wanted to use rise over run to find the gradient, 12, 6, we'll get a gradient of 2. And then one method I like to use is just count backwards to figure out what it would be at 0. If we're going back 2 each time, 3 would be 10, 2 would be 8, 1 would be 6, and 0 would be 4. We know at our y-intercept, x is always equal to 0, so we should get a y-intercept of 4, gradient of 2, and we can put that together to get the equation. I'm not sure why the question was set up in this order. Just give another 30 seconds or so for those of you who are still working. Lena, is everything perfect? Looks like Mega is on her way. Another way you could find the equation of the line is just, we know one of the points and we know the gradient. So I know that y equals 2x plus c. And then I can pick one of the values, let's say x equals 4, y equals 12, and I can substitute those in. So instead of y, we've got 12. That's equal to 2 times 4 plus c, which means c is just equal to 12 minus 8, which is 4. And that gives us our equation, y equals 2x plus 4. Would you like me to go over another one, just a nice simple one like this? Or we can move to the next one. So just remember, every linear equation is of this form. Y equals mx plus, no, not plus b. Used to be plus b in some states. In America, they still use plus b. A few other places, they still use plus b. As we draw 4x plus c. So m is our gradient, or the slope. Tells us how steep the graph is. And c is our y-intercept. Excuse my handwriting. Yeah. All right, let's move to the next one. Turn off annotations. Oh, clear. Okay, so in this case, we've got the graph already given. Similar questions. What is the gradient of the line? What is the y-intercept? And then write an equation in the form y equals mx plus c to represent the temperature of the room, y in terms of the time x. So here we have a graph, x-axis has our time in minutes, y-axis shows the temperature of the room after the heater has been turned on. So So a few ways we can look at the gradient. You might want to pick two nice clear points to read off the graph. We've got ourselves a right angle triangle. And then we can see this has gone across 8 from 0 to 8 and has gone up 2. Or remember, of course, we could use our gradient formula. y2 minus y1 over x2 minus x1. So for y2, x2, we'll generally pick the rightmost point. So let's choose that point there. We can see y2, if we go across, is 6. y1 was at this point here, is 4. And we know that was equal to 2 because we just eyeballed it. When you have only positive numbers, it's easy just to, especially if you're starting from 0, it's very easy just to read the numbers off. If we had something like that across the quadrants, and so we've got negatives to deal with, might be easy to use the formula or to think about how far that much is, and then how far that much is. So if you don't like remembering formulas, it gets a bit tricky. Just think logically about what the answer would be. Okay, so this was y2, so x2 must be 8. Y1 was 0, so we get 2 over 8, which simplifies to 1 on 4. You can see that there, obviously, if we go up 4, cross 4, we've gone up 1, cross 8 up 2. So from cross 1, we're going up by 1/4. So m equals 1/4. What is the y-intercept? That's just this point here. Sometimes you'll be asked to give the coordinates of the y-intercept, 0, 4. In this case, I think the answer they probably want is just y equals to 4. Or some of you have written c equals 4, that would be fine. Obviously on paper, in a test, probably any of those answers would get you the marks if this question hasn't stated what form to write it in, so all 3 of those would be correct answers. And now we know our equation is y equals mx plus c, and we have m equals 1/4, so y equals x on 4, or 1/4 x, and c is 4, so we have plus 4. So y equals x on 4 plus 4. A few of you got that so far. A few of you haven't joined the Pear Deck thing. The code's just here if you want to come in late, BBFTE, and then you'll be able to submit your answers online. If you said your gradient was 2 on 8, if that was a test, it would just depend how nice your teacher is, whether or not they'd accept that as a final answer. We should always simplify our fractions in cases like this where we can. Do you have a question on linearity? You had your hand up, I'm seeing. Just 30 more seconds and we'll just move on. Don't want to spend too long on this one. That was a nice answer from Lena. So we can write 1/4 x, or we can write x on 4. You could write 0.25x. They're all valid answers. Okay. So back to the same graph here. What does the y-intercept tell us? So we found this point, we found the y-intercept equals to 4. What does that y-intercept of 4 actually mean? Does it mean that the temperature of the room before the heater has been turned on was 4? Is it the time at which the temperature was 0? Does it mean the temperature of the room 4 minutes after the heater has been turned on? Or is it the amount by which the temperature of the room increases in the first minute? So this is the focus on this part, is really just interpreting linear relationships in a real life context. So what does the gradient actually mean? What does the y-intercept actually mean? What is the point in graphing it?
What are you doing?
Someone says they can't select in the Pear Deck presentation, but a few people have been able to. Were you able to join the presentation, Rishta? You might need to try again. Remember the code BBFTE. I can't see you on the list of students. Joshua is there, Lena is there, Manisha is there, Mega is there, and Onyinye. Ah. Oh, I see. I must have forgotten to include the correct options there. That was the answers from last week. My apologies. Okay, so sorry about that. Just put your answers in the chat. I definitely added these. I mustn't have saved it properly. Okay, got a bunch of answers coming in. So remember, the y-intercept is this point. Let me annotate. This is our y-intercept here. We can see that the y value, this point here, has coordinates of 0, 4. So our y value is 4, and we can see that the y-axis measures the temperature. So that means that the temperature is 4 degrees at this point. And we can see that the time here is 0. So after 0 minutes, the temperature is 4 degrees. So we can see that is this answer here. The temperature of the room before the heater has been turned on. Let's just quickly look at the other answers. The time at which the temperature is 0 degrees, we'd have to continue this graph all the way off to the left of the screen. Once that hit this line here, that would be when the temperature was 0. So we'd have to go back in time to see if that was the case. This one, the temperature of the room 4 minutes after the heater has been turned on. Well, 4 minutes is here. If we go up, we can see that the temperature after 4 minutes is actually 5 degrees. And the amount by which the temperature of the room increases in the first minute, can someone write down in the chat maybe what the answer to this one is? What is the amount by which the temperature of the room increases in the first minute, or for any minute? Between 0 and 1 minute, it increases by the same amount as it does between 1 and 2 minutes, between 2 and 3 minutes, and so on. What word do we give that? And if we go back to our equation we found, we have y equals 1 on 4x plus 4. So the amount that it increases in the first minute is this number here, 1 on 4, our gradient. The gradient is the slope. We can also think of it as the unit increase or decrease. So for every 1 minute in this case, the temperature increases by 1/4 degree, and this was our starting value, 4. So remember, if I sub in x equals 0, this is 0, this whole bit cancels out, and I'm just left with y equal to 4, which was this point here. Okay, let's go to the next one. I just cleared that. Okay. let's solve another contextual one here. Yep, right responses. This one should work. Carpenter charges a call-out fee of $90 plus $45 per hour. So the call-out fee is his flat fee. Doesn't matter how long you're using his services for. The minimum cost will be $90 in this case. And then you'll charge $45 per hour after that. So write an equation, y equals mx plus c, and then just state what the gradient is of the line. Now, I think there's a follow-up question to this, but I'll just give a moment or two. So remember, m is the gradient, and c is the y-intercept. Now, in the information we're given, we've got two numbers. Obviously, one of these is going to be the gradient, and one of these is going to be the intercept. So I think without knowing too much, we can probably narrow it down to one of these equations. Has to be of that form. We have two numbers, so it's going to be one of these answers. We know that if he was just charging the call-out fee and 0 hours were spent, it would cost $90. So that is pointing to this being our correct answer. I think all of you have that, which is good. Y equals 45x plus 90, and that means our gradient is $45 or 45. So if we were to graph this, the call-out fee is $90. So we'd have our y-intercept here at 90, and we know that after every hour, it's going up by $45. So I'm not going to draw this to scale. Obviously, 90's here, 1's there. That would mean that, say here, after 1 hour, it will be $45 more, so that would be $135. After 3 hours, say, it's going to be 3 times 45 plus the 90, so that's 120, 135, 225. One of you has, there you go, you've got the wrong way around. So this 45, or this value here, in this case here, plus 90, this is our flat fee or the y-intercept. So you can see here again, this is our y-intercept here, it occurs at 0.90, and that means that the minimum cost is going to be $90. Even just to call out the carpenter, it's going to cost you $90, and then $45 per hour. In any question like this, whenever you say something like per, which means $45 for every hour, that is always going to be our gradient value. So every time the unit increases by 1, the y value increases by this value here, our gradient. And that's how we get this. I think there's one more follow-up question for this one. Let me. We've talked about this, so it should be nice and easy. I think I put the right answers in to choose for this one. What does the gradient represent? Is it the minimum amount charged by the carpenter? Is it the total amount charged? If the wrong choices are in the options, just put it in the chat again. It is the wrong one. All right, let me just quickly actually change the answers. I don't think I can change them while it's running. We'll just stick to entering them in the chat. Yeah. B is the right answer here. So I need to remember C, the amount total amount charged for 0 hours of work. That would have been our Y-intercept. Remember, we have this as our formula. This value here, 45, is our gradient. So that would be, we know that $90 was the call out fee. So 90 is the total amount charged for 0 hours of work. That is the Y-intercept. And B is the total amount charged increases by $45 for each additional hour of work. And that is our gradient. So B is the correct answer. The minimum amount charged by the carpenter is the same as our Y-intercept, 90. And the total amount charged increases by $1 for each 45 hours of work. That's a very, very cheap carpenter. That's just the reverse of this one. So this would actually mean you had a gradient of 1 on 45. It would take 45 hours just to increase by 1. We're about halfway there, so I might just quickly race through this because I want to move on to looking at parallel and perpendicular lines. Just a couple more context ones, just so we're really on top of what it means. So the cost of a taxi ride, C, is given by the formula C equals 4.5t plus 9, where t is the duration of the trip in minutes. So the first question is just a simple substitution. What would be the cost of an 11-minute trip? And then for every extra minute the trip takes, how much more will the trip cost? So I want to solve, let's get a different color. C equals 4.5 times 11 plus 9. What's that? 4 times 11 is 44. Half of 11 is 5.5. 49 and a half plus the 9 gives me 58. It does 50, which is what most of you got. That's a pretty expensive cab ride. Might need to adjust the numbers for this question, make it slightly more realistic. And for every extra minute the trip takes, how much more will the trip cost? Looks like you've all got the right answer so far, which is awesome. Again, we're only looking at 2 options here. There's 2 numbers in the formula. It's going to be one of them, 4.5 or 9. We can see that this 9 is the constant term. Called the constant term because it's always there, it never changes. Whatever the value of t, we're always going to be adding 9 to that. So looks like you've all got it, which is good. For every extra minute the trip takes, it will cost $4.50 more. That is our gradient. Looks like one of you has maybe added the 9 to the 4.5. So this 9 only happens once. In the 0th minute, after 0 minutes, you get in the cab, your meter will already be reading $9. Now, I think in Sydney, it's probably about $3.50. I think it depends on the time of night or the day. In the daytime, it's a bit less. Middle of the night, this fee is a bit more. So it starts at $9, and then after every minute, we're adding only $4.50. We don't add the $9 again, it just gets added right at the start. It's what's commonly known as a flag fall. It's just another word for the constant term cost in a formula or in a situation like this in real life. Similar things for like making your phone calls. When you call someone, there's a fee right at the start. You can think of that as the flag fall. That's our constant term. And then for every minute after that, you might be charged per minute. Although now everything is pretty much free. You've got thousands and thousands of minutes free. 10 years ago, they weren't so lenient with their costs, and they charged quite a lot. All right, let's move on. Looks like you all got that. All right, constant value of 9. What would that have represented in this previous thing here? We just talked about it, so it should be nice and easy. Yeah. Toll charge. I guess that's the same as a flagfall. Another situation could be on a toll road, perhaps. You might pay a charge to use the road, maybe $3.50, and then you might get charged per kilometre you drive. So it might be $3.50 to enter the motorway, and then you are charged maybe 30 cents per every kilometre you drive. Yep, so let me just quickly show. All chosen the correct answer, a fixed cost, such as a toll charge. Awesome. All right, let's move on to parallel perpendicular lines. Halfway through the lesson, so the timing's working well. So now we've got 3 lines graphed. Y equals 3x, y equals 3x plus 6, and y equals 3x minus 8. They've all been graphed on the same number line. What do all of the equations have in common? Or in fact, what do all of the lines have in common? Should be pretty easy now. This is sort of just a quick recap. You would have learnt this in previous years, but we're going to look at a bit more detail. Yeah, got 3 responses so far, all correct. So assume you're probably all on top of it. It's clearly the gradient. If we look at the lines, you can see they're parallel. So what that means is if 2 lines have the same gradient, they will be parallel. They'll never touch each other. They'll all keep going off in this same direction and never touch each other. Right, yeah. Now, this would have been taught in Year 9, how to find the gradient between 2 points. So first, you might want to write down what the coordinates are and use them to work on it. You might want to use your formula. Remember, we have this formula, m equals y2 minus y1 on x2 minus x1, or rise over run. Now, obviously, the rise in this case is going down. So our gradient will be negative. Yep, so we have A, which is at -2, 3. The main thing here is make sure you don't forget your negative signs. So the first thing is identify that it's negative. We know we're going to have a negative answer. So if we end up with a positive answer, we've made a mistake somewhere. And now we have this point, 3 minus 4. You can see how they line up there. You might want to think of this as a triangle and use rise over run. If you don't like the formula, it's easy to go, well, from -2 to here is 2, and then from 0 to 3 is 3. So I know that my run is equal to 5, and my rise, I'm going from -4 till I hit the axis, and then from 0, I'm going up another 3. So I have a rise of 7. So in this case, -7, because we're going down. Again, y2 and x2 is generally the rightmost point, but if you pick the points the other way around, you'll still get the same answer. You'll just end up with a negative in a different part of the fraction, but the answer still comes out the same. Okay, so we should get a gradient of -7 over 5. Let me just use the formula and confirm. Y2 is -4 minus y1, which is 3. x2 was 3. x1 was -2. This is where I was saying, you've got to be careful with your negatives. -4 minus 3 is -7. 3, take away -2, means we're adding the 2. That gives us 5, -7/5. Just quickly, I'll show you if I did it the other way around. If I had 3 minus -4 over -2 minus 3, I've got 3 plus 7, sorry, 3 plus 4 is 7, -2 minus 3 is -5. So these two answers are equivalent. The difference is just where the minus is. The nicest way to write it is really with the minus in front of the fraction. You wouldn't include it on the numerator or the denominator. This answer and this answer are probably the two preferable ones. 7 over -5 is correct, but generally we don't write the negative sign in the denominator. We like to move it up to the numerator or have it outside the fraction entirely. Okay, looks like a couple of you used the formula, a few went straight to the answer using the points. It's worth knowing the formula. It's also just worth knowing how to visualize it using triangles. If you have to break it up into two pieces to account for the negatives, do so. Always be aware what the sign will be, and you should always get the right answer coming out. Quickly, just notice that -7/5 is greater than 1. Draw. So this is going to be, oh, sorry, less than -1. What am I talking about? Less than -1. So this is our slope y equals -x. You can see this is steeper because this is has a higher magnitude. It's not greater, it has a higher magnitude. It's going to be steeper. It goes down quicker. All right, next one. Clear, close. Okay, a bit harder now. We've got 2 points. We haven't got a graph. You might want to draw a graph of it. Might help. So we want to find the gradient of the line between A and B, and then we want to find the gradient of the line between C and D. So in this case, when you haven't got a graph, you probably do want to use the formula. But let's just graph it in the meantime. Do a very quick dodgy graph here. 2 minus 1, about there. B, 4. Oh, that's not 2 minus 1. Two minus 1, that's there. B, 4 minus 7, that's down here somewhere. I just draw the right angle triangle. I can see I've gone from 2 to 4, so I've gone across 2, and I've gone down -6. So I get a gradient of -3 for this one, which, yep, planar -3. Okay, what's happening with negatives? Quickly using the formula, I've got -7 minus, all right, yeah. So here, 4 is greater than 2, so I might as well think of this as x2 in this case, and this is x1. -7 minus -1 over 4 minus 2 gives me -7 minus -1 is -6 over 2 equals -3. Okay, Josh, it looks like you have probably flipped the two of these around. Your answer of -1 on 3 is just the reverse of this. So you maybe done 2 over -6 instead of doing -6 over 2. And quickly, yeah, so awesome. Lena has actually anticipated the next question. and stated that AB and CD are parallel, which was the exact point of this question. Let's quickly do this one again. So I've got 10 minus 1. I'm just going to pick this one as the second most point, even though this one is to the right, just to show you it doesn't matter. 10 minus 1 minus 6 minus 3. That gives me 9 on minus 3, which is also equal to minus 3. So we should get a gradient of minus 3 for both of them. I didn't draw these points. Let's just quickly. Minus 3, 1. You can be there. D minus 6 minus 6, 10. That's all the way up here. Running out of room now. C minus 3, 1 there. D minus 6, 10 up here. And even in this very rough drawing I've done, you can see that these two lines are parallel. If I drew it properly, definitely would be parallel. Okay. I won't show a demo of that one. Let's just move on. I should be clear. Oh, I went to a new slide straight away. Okay. Now this is slightly different. A line passing through the points 4, minus 3 and 1t has a gradient equal to minus 2. Find the value of t. Now we don't actually know what t is. We need to find that out in this case. Okay, 4 minus 3, let's say that's there, and 1t. We don't know where that is. We do know it has a gradient equal to minus 2 though. So if the gradient is equal to minus 2, it's obviously going to be sloping down. If that's y, that's a gradient of minus 1, let's say that's minus 2. So it's going to look approximately like that. This is our point 4 minus 3. Now, the easiest way to solve this, you can use the gradient formula. Always worth having the formulas in your bag of tricks, knowing how to use them. It is also worth just thinking logically without pulling the formula out, doing all these calculations. Let's just do a bit of thinking. I know here is 0, or x is equal to 0. And I know it has a gradient equal to minus 2. So if x has increased by 4, we know this is going to be going down minus 2 each time this goes across 1. So that's minus 2. If that's, let's say that's 1, it's gone down minus 2. If this is 2, it's gone down another minus 2. If this is 0, so 1, 2, 3, it's gone down another minus 2. So each time it goes down minus 2. So if we work backwards, it's going to go up 4 times 2. So this here is going to be 8. And if this is minus 3, I add 8 to that, I will get t is equal to 11. Oh, 1t, not 0t. Sorry, that's wrong. So it's only gone up, sorry, yeah. So from 4 to 1, it's gone across 3. Let's just think of it again. So we have this triangle. From 1, it's gone across 3. This means this has to have gone down 6. And so if we've gone down 6 and we ended up at -3, this point here, 1t must equal 1, 3. On union A, t equals 3, yes. Let's just check. Okay, now let's use the formula. Let's double check our working. We have y, so m equals y2 minus y1 over x2 minus x1 equals y2, let's just pick -3 because we know that one, minus t. Sorry, we know m as well, so -2 equals -3 minus t over x2. Well, we chose y2 as -3, so we have to choose x2 as 4 minus 1. Gives us -2 equals -3 minus t over 3. Take the 3 to the other side, we get -6 equals -3 minus t. Add 3 to both sides, we get -3 equals t. So looks like Mega and Onione have that correct. Did you use this method, or you possibly use a slightly different method? But there we go. T equals -3. I'll just quickly, where do we go for time? We're racing out of time. I won't show you another demo of that question. So next one. So collinear just means they all lie on the same straight line. Obviously, sorry, for any 2 points, they always lie on a straight line. Doesn't matter where my 2 points are, I can draw a straight line between them. I can't draw a straight line. If I could draw straight lines, I would draw a straight line between them. If I cheat, I can definitely draw a straight line between them. But if I have any 3 points, I can't necessarily draw a straight line between them. That's not going to work. Whichever one I pick, I won't be able to draw it through 3. So if I can draw them between 3 points, it means they're collinear. So you'll probably notice now, most of this topic involves using the gradient formula and then deciding whether things are either parallel, perpendicular, or on a different line. Okay, let me just draw a very small version of it down here. A and B have the coordinates -4, 3 and -2, 7. That just gives us a rough idea of it. And then C has coordinates -7, -3. So let's just assume they are. Let's assume they are on the same line. We'll draw them on the same line for now. So what we want to do is find this gradient here between A and B, and this gradient here between B and C. If they're the same, the lines must be collinear. Okay. So the gradient of AB is 7 minus 2 over -2 minus -4 equals 5 on 2. Did I do that right? 7. I did not do that right at all. That should be a 3. And then I've got MAC equals minus 7 minus, no, minus 3 minus C and B, 7 over minus 7 minus minus 2. Minus 3 minus 7 is minus 10 over minus 7 minus 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 2 is minus 5 equals 2. So both gradients equal 2, and that means that this must lie on the same line. If the point connecting here and here is 2, and here is 2, the point connecting here and here must also be 2. So they're definitely all on the same line in this case. Great. Most of you got that one. Awesome. Just very quickly cover everything else. I need to get to perpendicular lines. Based on the two gradients, are they collinear? Yes, they are. They have the same gradient. They must be collinear. I'll just go over this one quickly while you're having a go at it if you want. Feel free to just watch. It's always handy to draw lines. No, you draw the graph if you haven't been given it, just to visualize what's going on. So we know it cuts the y-axis at minus 4. It's here-ish. And it's parallel to the line y equals minus 3x minus 8. So if I was to draw that line, I know it passes here at minus 8, has a negative gradient, so it's going to look something like that. And I want to find the line parallel to it that passes through this point here. So this is the line we want to find. Firstly, we know it cuts the y-axis at minus 4. So straight away, I know my equation is going to be y equals mx minus 4. This is the y-intercept. It's always this part of my equation. Now, what else do I know? I know that it is parallel to the line y equals minus 3x minus 8. We just learned that if things are parallel, they have the same gradient. So this here must be our gradient. So y equals minus 3x minus 4. Oh wow, they stay on the screen forever. Just quickly show you here, this is just a nice applet that shows the lines in the graph. All right, so if I've got y equals minus 3x minus 8, let's just see if we can get that. There we go, minus 3x, oh, let's pull that down one more. Minus 3x minus 8 is this line here. I know I needed to pass through this point at minus 4, and I want parallel. And then we have minus 3x minus 4. We can see it's passing through this point here, and the two lines are parallel. Minus 3x minus 4, yeah, cool. All right, let's quickly race through. We've got about 5 minutes. I'm going to skip that one. Need to get onto perpendicular lines very quickly. If two lines are perpendicular, what is the product of their gradients? We know that for parallel lines, the product is just going to be whatever the gradient is squared. But what about if we have perpendicular lines? If I drew the two most obvious perpendicular lines, I've got my line y equals x, and then I have my line y equals minus x. That's close enough to perpendicular. So if I have y equals x, this means m equals 1. If I have y equals minus x, this means m equals minus 1. So if I have minus 1 times 1, I get minus 1 as my gradient. So that means that for any two perpendicular lines, the product of their gradient must always be minus 1. I'll just quickly show you on here. I cleared that. So you can see here, let's just do the one we just did, y equals okay, yes. So there you have y equals x, y equals minus x. You can see the right angles formed. If I take this to say y equals 2x, it's not perpendicular, but if I flatten that to become minus a half x, once again, we've got a parallel line. Take this up again, y equals 4x. We want to take this to y equals minus a quarter x. Again, I have my right angle. If I have the axes, I have this one, it falls down because m here is undefined. Let's look at our negative ones. Again, minus 4 and a quarter. Minus 4 times a quarter is minus 1. I have my right angle. Cool. Are these lines perpendicular? Y equals 3x minus 7, y equals minus 3x plus 6. It's almost 11 o'clock. If you don't mind, we'll go just a couple of minutes over. I only got a couple more slides to show. Let's just use this. Y equals 3x minus 7. Let's go down here to minus 7. Go across 1 up 3. And then we had minus 3x plus 6. Plus 6. Minus 3x plus 6. It doesn't look like they're going to be perpendicular at all. They're both rather steep. And they're not perpendicular. Ah, did I not put the right options in again? Yeah, makes sense. Yes, yes. Ooh. Okay, if we graph them here, y equals 3x minus 7 is going to look something like that. Minus 3x plus 6 is going to look something like that. They're going to be mirrored images around this point here. Does the y-intercept have to be the same as well? Not at all. In that y equals, like if I had y equals, sorry, let's undo that. If I take it over back to here, I can shift that up and shift that up as well. What have I got? Let's make that x plus 2 minus x plus 2. So all I've done there is taken y equals x and y equals minus x and shifted them both up 2. This is using the intercept to plot, but they might meet over here. So you can see here, x minus 2 minus x plus 2. The point of intersection is here. Or if I can move that up 2 and that up 2. Minus a half, let's get that to 2. Again, here's a perpendicular point where they meet. Minus a half, 2. So when we're looking at it, we don't care at all what the intercept is. We're just looking at this m term, the gradient. Okay. So they're not perpendicular. Here we go. This one's a bit different just because the order has been changed. So here, even though it's in a different part of our equation, this here is our gradient, minus 3 on 2. Really important not to forget the sign. So we have one gradient here, which is minus 3 on 2. The other gradient here, which is 2 on 3. If I multiply those together, minus 3 on 2 times 2 on 3, I'm left with minus 6 on 6, which is minus 1. And I get that they are definitely perpendicular. So I probably didn't include the right multiple choices here. Our answer here is yes. And one last thing we'll go over. I know you've probably got other classes to go to. Oh, that's the same one, easy. Just this is the other type of question you'll get. So similar to the one we looked at with the parallel lines. Line is perpendicular to y equals 5x minus 4 and cuts the y-axis at 1. Now let's 5x minus 4 cuts the y-axis at 1. Let's jump over to here, 5x minus 4. Let's go to minus 4. So here I've got 5x minus 4. That's the one line I know. It's perpendicular to that and cuts the y-axis at 1. So that's 1. Let's just manipulate this till we get a right angle. There we go. If that gradient was 2, obviously, this has to be minus a half. If I do, so one way you can do this mathematically, I know that 5, I changed my thing. So 5 times m, whichever, let's say m1, that has to equal minus 1. Dividing by 5, I get m1 equals minus 1 on 5. What did I do here? I must have switched to 2. So here I know that m is minus 1 on 5. And then that gives me this equation. Let's just say minus x on 5. That's the same thing. Minus 1 on 5. X is minus x on 5. Cuts the axis at 1. So I get my equation. Y equals minus x on 5 plus 1. Any questions quickly? We'll have to wrap it up now. So the most important things to take from this so if m1 times m2 equals minus 1, then the lines are perpendicular. If m1 equals m2, then the lines are parallel. And of course, every linear equation is of the form y equals mx plus c, where m is the gradient or slope, and c is the y-intercept or constant term. And of course, we have our gradient formula, m equals y2 minus y1 over x2 minus x1. M is negative, the line slopes down. M is positive, line slopes up. The higher the magnitude of m, the steeper the line. If you remember these 5 or 6 things, you'll be able to do any question involving perpendicular or parallel lines. You'll get a lot of perpendicular questions like the parallel one we looked at. So a line passes through the point 3, 6 and is perpendicular to the line y equals 7x, for instance. Okay, guys, hope you all enjoyed that lesson, got something out of it. I'll email out the slides, but I might quickly tidy them up and add the right links. So some of the links to the questions might not be correct. If you have any other questions about this, please feel free to just reply to the email or just email me directly, and I'll be happy to help you out, guys. All right. Thank you. Have a good week.